Michelle Ho, and I teach 3rd grade at Westlake Charter School. And over the summer, we decided to purchase a couple of 3D printers for our school to kind of play around with them and see what they're all about. And I've sort of taken the lead on this project at Westlake. And so I've been creating a lot of things and seeing what works, what doesn't work, working with different interfaces and things like that. So some things are like coasters. Those are fun to print and create. I created a dog tag for my dog, but it's kind of big, I realized. That was like a first attempt. I'm on this like keychain kick, and so I've been really loving creating a whole bunch of different keychains as well. And a bowl just to see how to use TinkerCAD, which is what I like to use to create and design. And then this is actually one my coworker created the other day on TinkerCAD, and I had it printing this morning, and it printed in time. And the New Matter store, which these are New Matter 3D printers, have like free things you can print. And so there's this awesome like sphere that I printed out just to test out, and like a 4x4 cube that nobody seems to be able to figure out how to put it together. It's been a lot of fun trying out the 3D printing process. So right now, I want to kind of get a read of the room, and the question I want you to think about is, how much do you know about 3D printing and design? And just to give you a frame of reference, a 5 would be like, oh, I'm on TinkerCAD all the time. I print things out all the time. I only eat on 3D printed items like plates, forks, knives. And the shirt that I'm wearing, I was so excited to be here that this shirt is 3D printed. If that's you, you're a 5. A 1 would be, oh, so this is 3D printing. And I know that if you do this, this is 3D. And a 3 would be, okay, I know about 3D printers. I've been on TinkerCAD. I've worked around with it before, and I've had the chance to send my item to a printer and watch it get printed. Just to give you a frame of reference as well, I would say I'm about a 3.5, creeping up on a 4 possibly, but that's what I'd give myself, a 3.5. So go ahead and show me your own rating. Great, awesome. Thank you. Just getting a feel for the room. Okay, so I want us to look at what the session overview is for today. First, we're going to take a look at TinkerCAD, the website, and then talk about how you can make purchasing possible in your own school. And then we'll have the chance to explore TinkerCAD together, how to create 3D items and how to build. And then I'm going to give you guys plenty of time to play today during our session as well.
So I have a question while we're waiting.
Yeah.
Are these the ones, this is what you use?
Yes, uh-huh.
And these are like the ones that are pretty inexpensive.
Yes, we bought a 3-pack bundle from New Matter. It's like the education bundle, and so pretty inexpensive, I'd have to say. Mm-hmm.
And then do you know, is the filament about?
I didn't purchase the filament. I was just going to take the filament that came with it, but the business office decided to purchase a whole bunch of different colors, and so I was pleasantly surprised when they arrived. Yeah.
Those are actually, I bet they're universal in printers, huh?
It depends on the 3D printer. That's what I found in my research. Some 3D printers can take any filament, and some they want you to buy their specific filament, and so that was something that either deterred me from other printer companies. So looking at TinkerCAD, anything that's underlined would be hyperlinked on my presentation. So taking a look at TinkerCAD, after you have a login and you sign in, you would have this kind of dashboard ready for you. And so these are a couple of things that, as you can see, that have been created. And the item that is actually printing right now on the Westlake 3D2 is this CapCUE keychain. So that's what is being worked on. And if we open it up, if I want to get a closer look, it's all these different layers that were created, and so you see it kind of pull up and it has all the different layers and it'll merge into one. So this was the initial design, and you can like swirl around and look at the keychain that was created on TinkerCAD. So I love TinkerCAD. It's free and it's very kid friendly, and I find it easy to use. So if you also don't know about 3D printers, how it works is that there's this PLA filament that feeds in through the back, and then the printer head is right here, and it heats up the filament, which is plastic, and then the plate moves on an X and Y axis, so the printer head doesn't move. The printer head itself does not move, but the plate moves, and then as the plastic is getting melted and the plate moves, then it creates the design that you made on TinkerCAD. Okay. So if you're interested in 3D printers for your school, the beginning process for me was really doing that research and having a strong argument for why I felt that having these would be beneficial in the classroom and at our school. So I went through a purchasing process where I looked at different 3D printers, compared and contrasted price points, options, and features, things like that. It's linked here if you want to take a look at it. It's there for you if you feel like you want to present something, whether it's to admin who would be supplying the money or whether it's to your PTA or donors. And I felt with that information tied with the standards, it was a hard bargain for them to say no sometimes. And so I just pulled a couple of standards from art and science, but there's so many more out there where 3D printing could be applied. So just to give you guys a couple to have in your back pocket though, if you're going to present this to whomever it is that is donating. And then if that's not enough, then there's also grants, Donors Choose, Digital Wish, things like that. And I have a mini description about each one, but if you want to know more, each of these are linked so you can click and get to the website to find out more about what you could do to get those. The only thing is that I think that this one, Save on Energy, the timeline is coming up pretty soon for that one. So, and I also curated a couple resources when it comes to 3D printing. The one we're really going to focus on today is TinkerCAD because that's where you do the designing process and everything. But there's a lot of cool things out there, and so later on when you have the chance to kind of look around, these are some great resources and people to follow on Twitter. And thinking about the future, where 3D printing is going, it used to be that when you think about the big picture about 3D printing, it used to be that NASA would send things out to space and it would cost billions of dollars to send things out there. And now what they're doing is that they're equipping astronauts with 3D printers and filament. And so now while they're out there, if there's anything that breaks, anything that they need, they have the means to create it right then and there. And if you think about our students and where they are now and where they're going to be by the time they graduate or they're looking for that job, 3D printers have also made it a lot easier for entrepreneurs because the costs are low and you can create your product and get it out there. So we really want to prepare our students for those 21st century skills and what's to come. And what's to come, sometimes we don't even know what that might be. Okay, so right now, there are 3 steps that we're going to do today when it comes to 3D printing. We're going to get a chance to log into TinkerCAD. We're going to design and share. And it'd be really cool if we could print some of these items out as well today. So if you open up your devices, you can go to tinkercad.com and go in the top right corner and click sign in. Currently, we have not gone on to TinkerCAD yet, but I'm imagining that I would have one username, one login, and then they would all create, and when they create, then they would call it like their name so I know whose it is, just to keep it easier that way. To be honest, I haven't figured out if TinkerCAD has a limit on how many people could be on at once. Like if I have 10 people sign on and all of a sudden it's like, wait, you're logged in 10 different places. Right now I'm logged into 3 and it hasn't said anything. So it'd be nice if it was just one login. If you're in that middle of the tutorial, you'll see in the top left corner it says exit. So you can click the exit out. Exit lesson. And then if you're not on this like home dashboard screen, you could click on the TinkerCAD logo and it'll take you to this home screen. And I want us to get a chance to work on a couple of key features when it comes to 3D design together before I set you guys off to do this on your own. There's 2 different options that I have: create new design, create design with beta. I still like to use just the blue one because the beta doesn't have all the features that the one that it started off with has yet. So I'm still working with the blue one currently. So go ahead and click Create New Design. So this is what we call the work plane. And something important to note are these arrows off to the side. So if you press the down arrow, it'll spin the work plane for you. And after it spins as far as it can, it stops. You can also turn it left. That's right. You can turn it right, and you can turn it left. And then you also have the zoom in, zoom out function. And then on the right-hand side, there's a whole bunch of things, like you have the work plane option, you have shapes. If you click it, you'll see all the geometric shapes that there are. There are also holes that you could work with, letters, and numbers. If you're familiar with Google Draw, a lot of the commands on this is the same as Google Draw, such as if you press Shift and you hold a corner and you move it in and out, it keeps the shape proportional, or clicking and dragging and things like that are the same. Right now I'd like us to let's take a box and put it on our work plane. You can manipulate the box in a variety of ways. You can make it long, wide, things like that. The corners are what makes it longer or wider, narrower, things like that. And as you can see, as I'm moving it, it's telling me in millimeters how big I'm making this shape. I like to have Google open on the side to transfer millimeters into inches because I'm not very familiar with millimeters. You can change the grid to inches, but you become less precise when you change to inches. So I like to keep it millimeters. And then if you look, there's a square in the center of my shape. And if I were to take that square, I can pull up to make it taller or pull down to make it thin. So those are a couple of important features when it comes to shapes. Go ahead and make maybe your square thin, pretty thin, and then click and drag over a cylinder. And as you can see, it's the same exact thing. Corners make it wider. You can make it more of an oval shape. And if you want to keep it a perfect circle, when you press that Shift button, it'll keep your circle proportional so that everything's moving at the same. And then that square in the middle, once again, makes it tall or short. And then go ahead and make your cylinder tall and put it in the middle of your square. So then, as you can see right now, my shape is a color, and I can change the color if I want. Just if they were both red and I want one not red, so I could differentiate between the two. Or I can make my other shape a hole. And then what happens there is that now I've created a hole in the middle of my square. The square and the cylinder are two separate items. So if you wanted to get an idea of what it would actually look like, you would click and drag to select all of the items. So I'm just clicking and dragging. And then I would do what's called group. And if I group them, all of a sudden I'm merging those two items together. They were once two separate things, and now I'm just going to make them one thing. So if I group it, all of a sudden now you see I have the hole in the middle of my square. Sometimes I like to do that to see what my design, get an idea of what my design is going to look like. And it's very easily undoable. I can click and drag, and I can say, okay, ungroup, that's not where I want it to be. I could put my circle in the middle of my square. I would then do the click and drag to highlight and get both items. And if you look at this adjust button up at the top, it will say align, and that's what you want to do. Once you click align, these dots will pop up, and you just decide which way you want to align it. Do you want the circle aligned all the way to the left, all the way to the right? But Ashley's asking for centered, so that's centered, and then aligning it this way, making it centered as well. And maybe sometimes I want to rotate my work plane to see what it is that I'm doing.
Could you group again?
Yes. So I would just click and drag to select all, and then I click the group button. And once they all become the same color, you'll know that they're grouped. I'm going to talk about two more things before I set you off on your own. One of the things is that make sure that or how to raise or lower items, because when it comes to letters, let's say if I want to put my initial on it, an M, maybe I want to make that blue so I can tell it from the square. So if I want to put my initial on this square, and I'm like, okay, here you go. But maybe sometimes I want to raise or lower the item. What I, on a Mac, would press is Command and the up arrow. Here, I'll move. Command and the up arrow, and as you can see, I'm moving it up, or Command and down arrow. I believe on PCs it would be Control and up, Control and down. And and what you want to make sure is that if you do have items that are floating or up, that they're at least all touching a surface, because then when it prints, it'll be able to print that item. If it's all the way up here, it's not going to be able to print correctly on the 3D printer.
So what would be the point of raising it like that? If you can't print it?
Because sometimes I might want to put an item underneath there or stack items, and then, or sometimes if I want to do what's called make a hole with the letter M, if I want to make M a hole, and I don't want the M to go all the way through, like these are all the way through, but maybe I don't want it to, like for these, CapCUE, I didn't want it to poke all the way through, so then I raise it or lower it. And then I can manipulate my work plane so I can see what it is that I'm doing. And then if I were to group these items, you can see that I've then created that indentation into the surface. That was a lot of information, but I want you guys to have ample work time to kind of see what it's actually like when you're getting in there to work with these different things. TinkerCAD does have a command list or a list of shortcuts that you could do on the computer. So like keyboard and mouse shortcuts or general shortcuts.
And how did you just get there?
This is a screenshot, but if you go to TinkerCAD's, if you click in my presentation, you can get to where it is on their
presentation.
Or TinkerCAD has it on their website as well, all the way at the bottom of the Learn. So when it comes, I'm going to give you guys time to work, and when it comes time to work, some people might be like, well, I have so many ideas of things that I want to create. I have so many things that I want to do. Just as suggestions, some of my personal favorite things to create are like keychains, home decor, like a bowl, a coaster, a jewelry plate, or something practical like a dog tag, pencil cup, things like that. So just see what you can create and design, and I'll be circulating to help out. But I'll be calling us back in about 10 minutes to kind of give you my top 5 things to look out for while you're creating. So you guys have about 10 minutes for now to design. How's it going? What are you creating?
No, I'm theoretically thinking I could make a ball a keychain. I messed around with
A ball, a keychain.
If you stuck this inside.
Right. So you might have to make a hole first in the ball to then insert the loopy thing.
Is this too hard? Should I just?
No, I'd say it's worth a try.
That would be cool.
Yeah. Because did you see what I don't think you were here when I was messing around with this, but this is one at the New Matter store. It's free on there, and so I just want to print it out to see what it's like. They did this.
Oh, that's a good.
Whoever designed that.
For a fidget toy in my break station.
Yeah. So I heard if you pull hard enough, it does come apart, but like I don't know if Kinders would.
Well, you never
How much does
know.
the filament
This
cost?
is so cool.
Costly to be printing these things?
$50 a roll. Yeah.
It seems like it lasts a long time though. What I found, I thought it would be crazy expensive, but it's, even one project that looks really big doesn't take
Yeah.
as much filament as I imagined it would.
Yeah, and that's something that we were talking about that we want to look into, like how many things could we get per roll, and like how much waste are we creating also, like, but we haven't gotten there yet because we're still in like the stage of like feeling it out and getting the hang of it.
And I bet you they're gonna come up with some nice generic filament as this gets more popular.
Right, right. I've seen other different kinds of crazy.
Specific to your machine, what filament you
We bought New Matter filament, I think just because it was easier that way. We're buying the printers from New Matter, buy the filament, but you don't have to buy theirs. Okay, I'm gonna go ahead and bring us back to kind of have you guys look at what you've been creating and ask yourself some of these questions. as I'm talking about these 5 things to look out for. One is the design size. It's in millimeters right now, and so if on your work plane, it's like, oh yeah, that's exactly what I want, that looks great, but it turns out, oh, this is 10 inches. 10 inches wide, 10 inches tall. So definitely double check the size, not only the size of it this way, but the height of it as well. So checking the millimeters to see the thickness. The print plate specifically for new matter is 6 inches by 4 inches, so that's what we're kind of constrained to there when it comes to that. And then the second thing to think about is what I said, the design thickness. So now that you know the size is good, are you at like 5 inches thick for something that you only want like 2 inches or 1 inch? And then are all your shapes touching? Because I noticed some people are clicking and dragging over several things. And then possibly if when you turn your work plane surface, you're like, oh, I thought that was on top of my keychain, but now all of a sudden I realized now that I turned the surface, it's hovering. Or I thought that was on top, but it looks like it's actually below the surface. And new matter, it's not going to be able to print things that are below the surface.
Nor above the surface, it has to be right on the surface.
It should be on the surface. Yeah, I haven't tested the waters to see what happens if you have something floating, but
Is there a way to just, instead of doing the raising it up and down, is there a way to just have it snap to it? Or?
yes. So if I were to zoom in, let's say, and we're taking this O, I could click the adjust button, click align. Oh, I guess that's if I have it over here. There is a feature, there's a shortcut. I can't remember off the top of my head, but there is something where you press and it'll push it back down to the work plane surface to have it all level. And then another thing to look out for is thinking about the color. If you're designing something in 10 different colors and you're like, this is great, I want that to be red, I want that to be blue, just so you know, new matter can only print out in one color, so the things are just going to come out solid. So sometimes our designs need to be a little adjusted for that idea as well. And then as for holes, if you are choosing to create holes, ask yourself if you want the hole to push all the way through your design, or if you want it to only kind of make an indent into your design. Because like this, after I printed it, I took it off, I was like, oh, awesome. Oh, I lost all the middle parts of all my letters. And so just something to consider.
Hey, Michelle,
Yes.
the 3 that you have, do you have them connected to a specific computer or are they on your network?
So that's a great question. I have to have them connected to laptops because the new matter printers can't connect to 5 gigahertz, and our school uses 5 gigahertz internet for our Chromebooks. So then the tech team had to get me MacBooks to then USB connect them to then print. Yeah.
So each one is specific to a computer.
And I've tried from one computer printing to 2 different printers, but then that kind of like gunked things up a little bit, and it caused what I was printing to freeze.
And their account on your teacher's.
You can share through TinkerCAD. Yeah, they can share you the link to their design as long as it's public, and then you can then physically be the one to print it. So it's looking like we have about 13 more minutes in this session, so I'll give us about 5 more minutes to kind of play around on TinkerCAD and make our designs. If you have something that is ready, I have a link on one of my last slides, or if you don't have my presentation in front of you, I have that link up on the board. Something that I did want to share out with you guys is that I printed out CapCUE keychains, and on the print plate, I can fit 4 of these keychains. And 4 of these keychains, this size, takes about 7 hours to print. So that's just something to be mindful of. It's not a quick process. It definitely is long. And if things were to happen in between, then it just extends your time for printing as well. Yeah. Yeah, you're welcome.